Hey there, everybody. Welcome to our homework video number 3. This week we're learning about synthetic materials. All right, in class we're doing our group poster project, and you're also reading about synthetic materials in your textbook reading. Okay, so throughout the video, remember that I'm going to be giving you 3 secret words, and just like last time, don't forget to submit them in a list just like this underneath your 5-sentence summary from your reading. All right. Also, please remember to write your 5-sentence summary in your own words, and copying directly what's in the reading is considered plagiarism, and you'll get a 0. Okay, so make sure you write it in your own words if you're not already doing that. Thank you. All right, so this week we're talking about how humans use chemistry to change things found in nature into synthetic products. Okay, synthetic, just to remind you, means human-made or man-made. It's not something that you'll find out in nature. For example, you may find metal ore out there in nature underground, and we go out there, blow up a mountain using dynamite, and we find metal ore. But these I-beams, which we use to build houses and skyscrapers, we're not going to find that in nature. That was synthetic, man-made, right? So, but what we do is in order to make this I-beam, it's called an I-beam, by the way, because it's in the shape of a letter I, if you look at it from this angle. In order to make the I-beam, we need metal ore, right? Because the I-beams are made of metal. A couple of different types of metals mixed together using chemistry. So what we do is we go out, dynamite different parts of certain mountains that contain certain metals, and we use the metal ore. It goes through many chemical processes to extract the metal from the rocks and separate it from the dirt and the metal and all the other stuff, and then we use it to make the I-beams. Okay, here's another example. Wheat and flour, right? Flour, which we use for bread, cereal, all kinds of baking, cakes and stuff. It comes from wheat, which is a plant that grows, right? You won't find flour in nature. It needs to be made by humans. It's synthetic. So this is just another example of something that we use every day, or if you don't use the flour to bake, you probably eat it every day. If you eat bread or cereal, or noodles or tortillas, right? And that stuff comes from a natural resource, wheat, the plant. All right, I want you to think about this. What properties would be desirable for the materials used to build airplanes? Okay, in order to fly an airplane, it needs to be lightweight enough to rise up into the sky, but strong enough to carry, let's say, 100 people who are on the plane. And once you get up there into the atmosphere, it's going to be cold temperatures. The air pressure is going to be different from what it is on the ground. And there are all these factors that you need to consider. So thinking about that, you can't use things that you find directly from nature in order to put into the plane as you're building it. No, you need to synthetically make certain materials like carbon fiber or aluminum alloys. That's what most airplane the body of the airplane is made of. You need to create it synthetically, man-made, using chemical reactions from, it still comes from natural products, right? And natural resources that we find in nature, but we need to change those to create a new material that suits our needs. All right, think about this. Scuba tanks, right? People use scuba tanks, and we go deep underwater, and the scuba tank metal has to be a certain type because it's always going to be in water. We don't want it to rust, right? That's going to mess up how good the tank functions. But we still need the metal to be strong enough to withstand pressure. We don't want it to crush if we get too deep. It needs to be strong enough, but then again, we don't want it to be too heavy because, the people who scuba dive, we carry it on our backs. So we don't want it to be too heavy and weigh us down. The harder we breathe, right? If we're carrying this heavy thing, the harder we breathe, the more air we use, and the less effective the whole idea of scuba diving would be. So scientists need to think about what material, what metal we need to use that's going to fit our needs. And then we develop the exact type of metal we need based on what we need it for. Okay, think about this. There are pros and cons to using plastic bags versus paper bags. Imagine if we're going to the grocery store and we need to carry 2 gallons of milk, right? If we're using a paper bag, 2 gallons of milk is probably not going to be a good choice. Paper is not going to be a good choice for that 2 gallons of milk, because when you carry it, it might rip. Even if there's a tiny rip in it, it's going to rip all the way down, and then you're not going to be able to walk home with your 2 gallons of milk. But plastic would be a pretty good choice, because even if there's a rip in it, the whole thing's not going to tear, and plastic is very durable and sturdy, and you could probably carry 4 gallons of milk if your arm is strong enough to lift it inside of this plastic bag. And there are cons of each too, right? Negative cons for using each one. Plastic, obviously, it once it goes into the environment, it stays in there for thousands of years. It can end up in the ocean, where it's just going to remain as a plastic. It doesn't disintegrate or biodegrade. Whereas paper, within a few weeks, it'll turn back into to dirt, or to fine pieces that eventually go away and dissolve. So pros and cons of how long they last in the environment and other things are always important for thinking about when we talk about synthetic materials as well. All right, I just want to talk to you about some cool synthetic materials that scientists have created. Look at this thing. This thing is called Aerogel, and it's basically a Jello. And what they did was they took a Jello and they use special equipment to take out the liquid parts of the Jello, and instead of the liquid, they squeezed back in some gas. So they took a Jello, removed the liquid parts, put some gas in it, and now you have this really lightweight, made of silica thing called Aerogel. It's super strong, and it's a really good insulator, which means that heat does not flow through it well. That's what it means to be a good insulator. So check it out. This person is lighting this part of the aerogel on fire, but it's not catching fire. And this plant, which is a delicate thing, is not being heated up at all. That's how good of an insulator this thing is, because of its special synthetic properties that we made. Very impressive, right? Yes, very, very impressive. So NASA is actually trying to use this aerogel to surround the re-entry capsules. When people go to space, they need to come back down to Earth, right? They come back in this capsule that they're inside, but when you're flying through the Earth's atmosphere, it gets really, really hot, and you don't want those people to cook inside of the capsule. So they're thinking about surrounding the capsule with this aerogel stuff to prevent them from getting too hot. So check this out. This spacesuit, which is being worn by Mae Jemison, the first Black woman to go to space, is made of 14 different layers, which is amazing that scientists have to think about. Okay, outer space, it's super freezing cold, below freezing temperatures. There's no air there. It's the sun's rays shining on you. The radiation is crazy because we don't get protection from the Earth's atmosphere since we're in outer space. There are all these factors to consider. And so what the NASA scientists did was they figured out that, okay, we need to make a spacesuit. And because of all the conditions that it needs to go under, it needs to be 14 layers thick. So this spacesuit is made of nylon, spandex, urethane, neoprene, mylar, Kevlar, Gore-Tex, Nomex, which some of you are going to read about for your group posters. But amazing synthetic materials that help astronauts like Mae Jemison be safe in space and not freeze to death. All right, the final synthetic, last two synthetic materials that are really cool that I want to talk about. One thing that scientists use for a lot of medical equipment and bulletproof vests and airbags is actually spider silk. Spiders make a web using silk that comes out of their butts. And in order to get the silk, scientists tried to make a spider farm and use a bunch of spiders, but they were too territorial. They started killing each other. So instead of having a spider farm, they decided, you know what? Why don't we take some of the DNA out of a spider and put it into a goat, okay, a goat like this, and have the goats make the spider silk instead. Okay, that being said, here's our first secret word. Our first secret word is spider goat. Okay, spider goat, one word. All right, so what scientists did was they changed the goat's DNA so that when the goats make milk, out of the milk comes not only goat's milk, but also spider silk. So it's much easier for them to collect big quantities of spider silk from the goat's milk. So weird, right? And they use it to make these medical products and bulletproof vests and car airbags, because that spider silk is so lightweight, but also so super strong that it can be bulletproof too. Another cool synthetic material, the last one I'm going to talk about, is hagfish slime. Okay, look at this beautiful fish, hagfish. It looks like an eel, but it is a fish. And they make this crazy slime. My goodness, look at this picture. Um, and people grow the hagfish inside of hagfish farms in these tanks, and then we harvest the slime to use for protective clothes, food packaging, maybe even a certain type of plastic that can disintegrate in nature, which is really cool. Bungee cords, band-aids. And our second secret word is telescope. Okay, telescope, like what we use to look at stars. And this hagfish slime is 100 times thinner than human hair, but 10 times stronger than nylon, which is really strong. So these amazing, synthetic materials made from natural resources like hagfish slime. And the way that we make it, turn it into these things, is by using chemistry and putting it through chemical reactions. Okay, last thing I want to leave you with is the Bronze Age. Okay, so there's this period of time in history, it's like something BC, a long, long time ago, when people first discovered that they can mix copper, which is a special metal that's inside of our pennies, they can mix it with another metal called tin and turn it into bronze. And bronze ended up being like this crazy revolutionary metal that changed the whole world, because people started being able to make really good weapons, shields, knives that don't bend when you're stabbing something. They started to make jewelry, which is very shiny and attractive. So trade all over the world, different countries exploded. And, there was a mixing of cultures. And all this other equipment that we didn't have before. And so basically what I'm trying to say is that the Bronze Age happened because humans started using natural things found in nature, which is the copper ore, and we use chemistry to turn it into a synthetic human-made product. And those things can change society. All those synthetic materials we make change society, right? Think about the airplane metal itself. We can now fly from here to Mexico in 4 hours. I could fly from here to San Francisco in less than 1 hour. That's amazing. If we didn't have that, then it would take me 6 hours driving. So these synthetic materials that are made by humans really do impact society, and they're created using chemistry, which is what we're going to learn about next week. Okay, our final secret word is stingray. Stingray. Okay, thanks for listening, everyone. See you in school.